So good afternoon, everyone.
Good afternoon, sir.
And let us start this class. Okay, not able to get the video on. What is this? Okay, just give me a minute. Okay, so what we were doing in the last class, I think we were doing work done by variable force, yes or no?
Yes, sir.
And I think I had given you a problem to solve
Yes, sir.
of work done by a variable force. Have you solved that problem? Did you get the answer?
Yes, sir. Minus 7 by 2 joules.
Okay, a force, that was the question that I had given you. A force xi plus 2yj is applied on a particle. The particle moved from this point 1, 2 to 0, 1, and you had to find out the work done by this force. And I think you have got the answer also, right?
Yes, sir.
And what is the answer? Let me check.
Minus 7 by 2 joules, sir.
My, let me see. I must be having that question. Minus 7 by 2, that is correct. Minus 3.5 is the answer I have. So that is correct. Well done. So I don't need to do this. You have already done this. Yes or no?
Yes, sir.
Now in this class, what we are going to do is we are going to see how we can find out work done from area under displacement. Yeah, force displacement graph. If you have a force displacement graph, from the area under force displacement graph, you can also find out the work done. You know this, yes or no?
Yes, sir.
So this is just a small diagram that I'm going to show you. I hope everyone knows this, and we can just quickly go through this. So if I have a force displacement graph, I can find out the work done from force displacement graph because this area that you see is nothing but integral of f dot ds. Do we understand this?
Yes,
This is the
sir.
integral of f dot ds, and f dot ds ka integral is basically work done by this force. Now, with this work done could be positive or this work done could be negative. As you can see, if the area is above your x-axis, work done is positive.
Positive.
Why it is positive? Because force is positive. The direction of force is taken as positive, and the direction of displacement is negative. Therefore, the area is positive. In the case of the second case, where your displacement is below, when the force is below the displacement axis, that means force is negative.
Negative.
Force is in the opposite direction, backward direction. Displacement is in the forward direction, and therefore you have negative work done. Do we understand this?
Yes, sir.
Now, one more thing that you would have seen is in the all the three diagram what they have done, and if I can highlight that, they have written here fx, and they have written here x, they have written here fz and fy and y, fz and z. That means if the force is a three-dimensional force which has got an x component, which has got a y component, and which has got a z component, and if you have graph of that force as well, so that graph will be drawn between, this graph is drawn between fx and x, this graph is drawn between fy and y, and this graph is drawn between fz and z. So how do you find out the work done by that force? You find the area of graph number 1, you find the area of graph number 2, you find the area of graph number 3, and then
Add,
you simply add them.
add them up.
Do we understand this, yes or no?
Yes, sir.
So this is how you can find out the work done by any force from the area under the force displacement graph. I will give you a question, and I hope you can solve that question and give me the answer. Okay. You noted this down now?
1 minute, sir.
Okay, note this down. Sorry. Noted this down?
Yes, sir.
Okay, then this is the question that I have. The relationship between force and position is shown in the figure in one-dimensional case. The work done by this force in moving the object from 1 to 5 centimeters. Remember, everything is given in centimeter and force is given in Dien's. So your answer will be in ergs, which is the CGS unit of work done or energy. Do we understand this? Can you find out the work done by this force? I'll give you a minute to do this.
A, sir. 20 hertz.
Everyone got the answer then?
Yes, sir.
So how are we supposed to do this? It is pretty simple. You have to find out the area under the graph. The area of this part will be treated as positive. The area of this part will be treated as negative. You can break
Yes.
it up. You can break it up into into rectangles, right? Yes or no? Rectangles or
Yes,
square or
sir.
whatever it is. You can break it up. Positive area, negative area, and you are done. Do we understand this? Yes or no?
Yes, sir.
Okay. That is what we call as work done from area under velocity force displacement graph. I will give you one more question on this because I suspect that you can get a question on this. So I'll give you one more. This one. A 10 kg mass moves along x-axis. Its acceleration as a function of position is given by this. What is the total work done by the force as the mass moves from x is equal to 0 to x is equal to 8 centimeters? Remember, this is given in centimeters and acceleration is also given in centimeter per second square. Give you 2 minutes to do this. Yes, do we have an answer, bacha?
1 minute, sir.
Okay.
Sir, A, sir. Sir,
Yes, sir.
A, sir.
Hey, sir. How did you get? Why did it take so long for you to get the answer? Was it such a difficult question?
Sir,
Yes, sir. Tell me, was it such a difficult question?
no, sir.
Okay, so the mass is given as 10 kgs and the acceleration is given as a function of x. So if I multiply this acceleration by m, I will get the force ma, F is equal to ma. Yes or no?
Yes, sir.
So you just find the area under this graph and multiply it by the mass. What is the area under this graph? Half into base. How much is the base?
8.
8 centimeters. So 8 into 10 raised to the power minus 2 meter. Yes or no?
Yes.
Then multiplied by height. What is height? 20 centimeter per second square. So that will be 20 into 10 raised to the power minus 2 meter per second square. Yes or no?
Yes, sir.
Multiplied by what? Multiplied by the mass, and that is the answer. Do we understand this?
Yes, sir.
Why does it take so long for you to do this, beta? It was a simple question. Yes or no?
Yes, sir.
Okay, I'll give you 1 minute to note this down. Remember, if any question like this comes, find out the area multiplied by the mass. Mass into acceleration is the net force, and area under force displacement graph. 1 minute to note it down.
Done, sir. Done, sir.
That takes us to the next heading. And the next heading is kinetic energy. So write the heading kinetic energy. Kinetic energy. Now, before getting into kinetic energy, we must understand what is energy. I hope you know what is energy. Energy is the ability to do work. Yes or no?
Yes, sir.
Okay. There are two types of energy that we are going to study here. One is known as kinetic energy and one is known as
Potential
potential energy.
energy.
Kinetic energy. What do you mean by kinetic energy? It is the energy processed by a body by virtue of its motion. Yes or no?
Yes, sir.
Kinetic energy Ke will be equal to half
mv square.
mv square, where what is m?
Mass.
What is v?
Velocity.
No, v is not velocity. It's better to call this v as speed because it is v dot v. So it gives the magnitude of velocity, which is basically speed. Remember, kinetic energy of any body is always positive. It's never negative. So instead of calling it as half mv square, where v is speed, is better to call it as half mv square, where v is speed.
Speed. Yes.
Because if I call half mv square and if I say v as velocity, it will give me a notion that if velocity changes, the kinetic energy will change. But it does not happen that way, because velocity changing, it may change in magnitude, it may change in direction, it may change in both. But kinetic energy only changes when velocity changes in magnitude. So instead of saying so much that kinetic energy will only change when velocity changes in magnitude, if we understand this as half mv square, where v is speed, it automatically means that when speed changes, which is the magnitude of velocity, then only your kinetic energy will change. If velocity changes, kinetic energy may not change because the speed may still be same. Do we understand this? Yes or no?
Yes, sir.
That is one thing that you must understand. Then kinetic energy. To find the kinetic energy at any point, you have to multiply mass with velocity or speed ka square. So it's an instantaneous thing. You can find out what is the kinetic energy at this position, because it is calculated from instantaneous speed. So kinetic energy can be instantaneous, but work done by a body is never instantaneous. It's always between 2 points. Do we understand this? Yes or no?
Yes, sir.
Now, once we understand kinetic energy, then there is one thing that you must understand. If you're applying force on a body, and right now we are dealing with cases where the body is not going to change its size or shape. If you apply force on a body, and if the force is big enough, the body will start to move. Yes or no?
Yes, sir.
Now, when body starts to move, it basically accelerates. Velocity may change. When we apply a force, body accelerates, its velocity is changed. We can say this in a different way, that its speed may also change. If its speed changes, its kinetic energy
Kinetic
changes.
energy change.
So basically, we can say that the effect of force on a body can be measured by the change in its kinetic energy. Yes or no?
Yes, sir.
And we call this principle as work
Energy.
energy theorem. What is this work energy theorem? This work energy theorem basically states that work done by all forces on the body is equal to change in,
Changing kinetic energy.
that means final kinetic energy minus initial kinetic energy, half mv square minus half mu square. Do we understand this?
Yes, sir.
This is known as the work energy theorem. And here, when we say work done by all forces, this means all the forces acting on all the bodies. If there are more than one bodies, we will find the change in kinetic energy of first body, second body, and so on. Do we understand this? Yes or no?
Yes, sir.
Then we have one thing, which is the relation of kinetic energy with momentum, the magnitude of momentum, I should say. Kinetic energy Ke can be written as half mv square. Yes or no?
Yes, sir.
We can also write it as we can also write it as what? I can also write it in terms of momentum. How can I write it in terms of momentum? I can also write it as half momentum multiplied by,
Where?
right? Or I can also write it p square by 2m. So these short forms may come into use when you require them. We can also write the reverse of this. Momentum can be written as 2 times kinetic energy by v, or you can also write it as 2 times m into kinetic energy root. So these are the different ways in which you can write this. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down.
Done, sir.
Okay, have you done this?
Yes, sir.
Then these are some of the graphs that you should remember. Basically, these graphs are coming from the equation that we have written. So please note down these graphs. This is the graph of kinetic energy. Graph number 1 is the graph of kinetic energy, where kinetic energy and V when the mass of the body is kept constant. We understand this.
Yes, sir.
Graph number 2 is the graph between kinetic energy and momentum square, whether you call it as velocity or speed square or momentum square, it is the same thing, yes or no? The third is the graph between, if I keep the momentum of the body constant, it is inversely proportional to the mass, so it will look like this. Fourth graph is between root of E and P. It is a straight line. I have seen a lot of questions come on these graphs, so please note down these graphs.
Done, sir.
Okay, so we have seen a few examples of relation between momentum and kinetic energy. Let us solve this question. Consider the following two statements. Linear momentum of a system of particle is zero. The kinetic energy of a system of particle is zero. This question has come in one of the previous exams. Tell me which is the correct option. Let me call this as question number 3. I'll give you 2 minutes to do this.
A, sir. Sir.
Think about it and then give me the answer. Beta.
A, sir. 1 implies 2 and 2 implies 1.
How can you say that? Have you read all the 4 statements?
Yes.
The correct answer is 4. It's not 1. Think again. Remember, momentum is a vector quantity. So direction wise, it can get cancelled. Kinetic energy is a scalar quantity. Direction wise does not get cancelled. So if kinetic energy, the total kinetic energy of a system is 0, that means the speed has to be 0. If the speed has to be 0, then the momentum is definitely 0. But if the momentum of a system is 0, that does not mean that the speed is 0. One can have momentum in this direction, the other one can have equal momentum in the other direction. Total momentum, since it's a vector quantity, it can be 0, but that does not imply that the kinetic energy is 0. Do you understand this?
Got it, sir. Yes, sir.
Think about it. You jump onto the questions. You jumping onto the answers very quickly. Read the question and then apply the answer. Okay. Let us say, let us say if you can do this one. Question number 4. Let's see. These are the type of questions that are coming these days. A body of mass 10 kg at rest is acted upon simultaneously by two forces, 4 Newton and 3 Newton at right angles to each other. What is the kinetic energy of the body at the end of 10 seconds? Think about it, get me the answer. Well, but are you trying or shall I help you out?
We are trying, sir.
Okay. Shall I do it? Gacha?
1 minute, sir.
Okay, I want you to do it right. Okay, I think I have given you enough time. It was not such a difficult question. How are you supposed to do this? It is acted upon by two forces at right angle, so you can find out the net force. What will be the net force in magnitude? It will be root over 3
2
square plus
plus
4
4.
square. So 5.
5, sir.
That is the net force. You have to find out how much work, how much is the kinetic energy at the end of 10 seconds. There are a number of ways in which you can do this. You can find out the acceleration of the body, that is first way. You can find out the acceleration of the body, that will be 5 divided by 10. That will be equal to half meter per second
Yes,
square.
sir.
You can find v is equal to u plus at. Acceleration is constant. After the end of 10 seconds, velocity will be how much? U is 0. Acceleration is half. Time is 10 seconds, so it is
10
5 meter per second. And to find out the kinetic energy, it is half mv square. You will get your answer. Was it such a difficult question that it would have taken so long? That is one way of doing it. You could have done it by a different way, where you could have used work energy theorem. To find out the work energy theorem, you could have calculated the displacement and then multiplied it by the force. That also you will get the work done. That work done is change in kinetic energy. Do you understand this? Yes or no?
Yes, sir.
Okay, I'll give you 2 minutes to note this down. Note it down this, beta.
Done, sir.
Comes the next question, and here is the next one. If the momentum of a body increases by 0.01%, what will be the change in its kinetic energy? I'll give you 1 minute to note this down. I mean to try it. Any idea how will you do this? The same question could be asked in a different way. If the velocity of a body or the speed of the body changes by 0.01%, what is the change in its kinetic energy? Whether I call it change in momentum or I call it change in speed, both are same things because both are changing because of change in the speed. So both the questions are same. How are you supposed to do this? So you can write this E kinetic energy Ke as P square by 2m. Yes or no?
Yes, sir.
Let me just write it as K. So K is P square by 2m. If I differentiate this K, dk, that will be equal to 2P by 2m. I'm differentiating it. 2P by 2m into dP. Do we understand what I have done?
Yes, sir.
I divide this by K. So this becomes divided by P square by 2m. Are you getting what I have done here? I divided it by kinetic energy again. So what happens is this 2m and this 2m cancels. 1p and 1p cancel. So what I get? dk by k is equal to 2 times dp by p. Do we understand this?
Yes, sir.
That's it. dk by k is the percentage change in kinetic energy. If I multiply it by 100%, on the left hand side, if I multiply it by 100, and on the right hand side, if I multiply it by 100, it is the percentage change. So on the left hand side, I have percentage change in kinetic energy. On the right hand side, I have percentage change in momentum. And what do I see? Percentage change in kinetic energy is 2 times the percentage change in momentum. Yes or no?
Yes, sir.
So percentage change of kinetic energy K will be 2 multiplied by 0
0.0.
0.02. Do we get this? Yes or no?
Yes, sir.
That is how, if any question comes, you will have to do it in this way. Do we understand this?
Yes, sir.
Okay. Remember this question, and some of this question would be coming in your exam. Okay.
Yes.
Okay. Now, since we have done this work energy theorem, let us do one or two more problems on this work energy theorem. Have you noted this down?
Done, sir.
Okay. Let us take this problem. Question number 1. This is ground. I have a block of mass m at a height h from ground, and at this point it is at rest. If I release it, what will happen? If I release this block from this height, what will happen? Yes? If I release this block from this height, what will happen?
It comes down, sir.
It comes down. It will strike the ground, or just before striking the ground, it will have some velocity. Yes or no?
Yes, sir.
With what velocity does it strike ground? That is the question. I'll give you 2 minutes to think about it and get me the answer. Acceleration due to gravity should be taken as g. Acceleration due to gravity is g. Can you tell me the answer for this one? 2 minutes.
Yes, sir. It's done.
What is the answer, bacha?
Root 2 GH.
Root 2 GH. How did you get it?
Sir, I taken as initial velocity as 0.
Okay.
Acceleration due to gravity is g.
Okay.
Displacement is h.
Yes.
And I have considered v square equals to u square plus 2as.
So basically what we have done is you have applied V square is equal to U square plus 2 times A. In fact, it is written as A dot S. Do you know this? A dot S, A dot
Yes,
delta R,
yes, sir.
dot product. Okay. Now if I multiply by M on both sides and divide by 2 on both sides, this is the equation that I will get. Two will go from here, obviously. Sorry. I hope you understand what I've done here, right? I have multiplied by M and I have divided it by 2. And if I now write it, you know what is this now?
Yes, sir. Work done equals to force into displacement.
This is the work energy theorem. Change in kinetic energy is the work done by all forces. The only force acting here was gravity, which was constant. Do you understand this? So whenever you have used this equation for constant acceleration, you have actually used the work energy theorem. You've actually used work energy theorem. Do you understand this? This
Yes, sir.
equation is same as work energy theorem. So I could have done this equation by work energy theorem directly, because this equation is only valid when the acceleration is constant, but this equation is always valid whether we have constant force, whether we have variable force, whether we have spring force, gravity force, or whatever force. Do we understand this?
Yes, sir.
So I could have done this in this way. I could have found out what are the forces acting on it. What are the forces acting on this body? There's only one force acting on this body, which is mg, which is the weight of this body. Yes or no?
Yes, sir.
In going from point A to point B, what is the work done by gravity? The gravity force is mg and it moves a distance h downwards in the same direction. So the work done by gravity is plus mgh. Yes or no?
Yes, sir.
This plus mgh should be equal to the change in kinetic energy. The final kinetic energy is half mv square minus the initial kinetic energy is half m u square. This part is definitely 0. Just yes or no? Do we understand this?
Yes, sir.
From here also you could have got the same answer. V is root over 2gh. So whenever a question comes, take it as an important note. Whenever they ask V, velocity of any particle at any point, 99% of this cases, the question will be done by which concept?
Work
It will
done.
be done by work energy theorem. Do we understand this? So that is a hint that if a question comes where they ask you the final velocity of the particle, 99% of the cases that question would be a question of work energy theorem. Do we understand this? Yes or no? No, yes.
Yes, sir.
Now let us try this question and see if you can do this and tell me the answer for this one. A body of mass m, when released from rest, is released from rest from a height h, hits the ground with root over gh. It should have hit the ground with root over 2gh, no? Yes or no?
Yes,
That
sir.
means there is some other force acting on this. Find the work done by the resistive force. So there is some other force acting on the body. You have to find the work done by that resistive force. I'll give you 2 minutes to do this. Shall I do it or you are trying?
Yes, sir. Done, sir.
What is the work done by the resistive force?
mg by 2, sir.
It is dimensionally wrong. mg is force. It cannot be mg by 2. What is the work done by the resistive force? Shall I do it or you want to try it again?
Yes, sir. Do it, sir.
Try it again. Draw a diagram and see what is happening. This is here at rest. Velocity is 0. It falls here. This height is h. It falls here. The velocity with which it falls, root over gh. How will you do it? Tell me. What concept have you applied? Can you tell me that? Bacha? Huh?
Work
Tell me.
energy theorem.
Okay. So you are going to apply work energy theorem. So I write it work energy theorem WET from point A to B. What does this work energy theorem states? Tell me that first. Work done by what? Tell me. What is the work energy theorem?
Change in kinetic energy is equals to work done, sir.
Work done by what?
All forces.
Nah, safe fully, na. Work done by all forces is equal to change in kinetic energy. What are the forces working here? What are the forces working here?
Gravitational force and resistive force.
Okay, work done by gravitational plus work done by resistive force is equal to change in kinetic energy. What is the change in kinetic energy? Final kinetic energy is half m. V squared is gh. Yes or no? Yes or no?
Yes, sir.
Minus the initial kinetic energy is 0. Can you tell me what is the work done by gravity in this case? What is the work done by gravity in this case? How much work gravity does in this case?
mgh, sir.
How much, beta?
mgh.
mgh plus work done by the resistive force is equal to mgh by 2, and you get your answer for work done by the resistive force. It will be minus mgh by 2, and that is the answer that you should have got. Why did not you get it? Tell me what was wrong.
Sir, I have found resistive force.
If you don't read the question properly, I don't know. You cannot find out the resistive force. The resistive force may not be constant. You can only find out the work done by the resistive force. Unless and until they tell you that the resistive force is constant, you cannot find out that resistive force. I don't know what you were doing. I hope you understand. You can always find the work done by any force. Work done by the force does not depend on how that thing is moving, whether it is moving with constant acceleration, variable acceleration, or whatever. Work done by the force is always integral of f dot dr, which can be easily calculated. Here we have calculated it in a different way. We did not know how much is the frictional force, how much is the resistive force, but we have calculated it using the power of the theorem, which is known as the work energy theorem. Do we understand this? Yes or no?
Yes, sir.
Okay, in the next class, what we'll do, we will be doing more problems on this. We will also try to understand the concept of potential energy, and we'll also try to understand the concept of the law of conservation of energy. That will be done in the next class, and probably by the end of this week, I am hopeful that we should be able to cover up work, power, and energy as well. Yes, beta. Any doubts? Anything that you want to ask?
Sir, what is the syllabus for this week, sir? Weekend exam.
What is the syllabus for this weekend exam? Everything that we have done
Till today.
till today.
Okay, sir.
Okay. So you might get question from work, power, energy. You might get question from Newton's laws of motion. You also might get question from motion in 2 dimension, motion in 1 dimension, units and dimension. Be prepared
Okay, sir.
for everything. Remember, we don't have so much time in our hands. So you might expect questions from all the categories. Okay.
Okay, sir. Thank you, sir.
Okay. And remember, the question paper will be of the standard of JEE Main. So if you score good, now we have covered some topics at least, so you can have a fair idea of how you are scoring. So let's see. Please try your best. Okay.
Sir, did you send that PPP of work, power, energy?